So one function, of course, that we like to need to use the inverse of all the time is the exponential function. And I'm just going to use natural exponent e. So then we're going to get natural logarithm ln. We know that here we have, for our exponential function, we have this asymptote at y equals 0. Now, if I want to invert this, I see I can invert this because it is 1-to-1. All I have to do is make sure that I don't have to worry about I know that the range is from 0 to infinity, right? So if I look at this, my domain is all of R, and my range is 0 to infinity, right? Not including the point at 0, which tells me that when I take the inverse, the inverse is, of course, called the logarithm. And so what I'm going to do, y equals ln of x, what does that actually mean? It means that e to the y equals x. And yes, we could take another base. I'm not going to use them very much in this class, and this is all review, so I'm not going to fuss with that. This y equals 0 horizontal asymptote now becomes this x equals 0 vertical asymptote. This is y equals natural log of x. And of course, our domain is 0 infinity, and my range is negative infinity, infinity. This point, of course, is the point 0, 1, right? Because e to the 0 is 1, because anything to the 0 is 1. That means that when I swapped over here x and y, this point is 1, 0, right? So that's going to tell you natural log of 1 is 0. Natural log of 0 is undefined. So I can write dne, or I can write goes to infinity. I don't care. For my purposes, what we're going to see is whenever you have natural log of something, you have to remember natural log of that thing can't be 0. And if I have natural log of 0 showing up, I better look hard and fast at what's going on. Okay? A lot of people will forget this, but don't forget it. Or put it the wrong way, natural log of 0 is 1 or something. We don't want that. Okay, so that's the logarithm, which you already know. I'm sure in pre-calc you did tons of work with logarithms, figuring out the number or whatever, blah, 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 all those problems. We won't be doing a lot with that, so I'm not going to fuss about it. I do want to remind you, laws of logs, because we will be using these. And it's a very common source of error, right? So you want to make sure that you're using them right. So natural log of x times y is natural log of x plus natural log of y. Natural log of x over y is natural log of x minus natural log of y. And natural log of x to the c, just by using this, c times, you can pull this, remember, pull the c down. That's c times the natural log of x. So these three, we'll use them a lot. It's important that they're this way. And in fact, you can show that they follow from the laws of exponents, right? Be careful. This multiply inside goes to a plus here. If I have natural log of x plus y, I can't do anything with that. So this is not equal to natural log of x plus natural log of y. It's also not equal to natural log of x times natural log of y, if somehow you got this one confused with that one. If I have a plus or a minus here, that's as good as I can do with that. I have to leave it that way. Okay? I'm trying to think of the biggest one. Probably it's something like this, where people do this or that, or just getting it backwards or whatever. So this is important to get this guy straight. Now, another thing, we talked about the cancellation equations, right? The cancellation of f inverse of x, doesn't even look like an inverse, equals x, etc. So in the context of logarithms, you got e to the natural log of x equals x, or natural log of e to the x equals x. You can also, what's the one? You can actually put both sides of this to the r. We'll use that sometimes. Basically, if I stuck this both sides to the r, or if I get confused, I can also just do this natural log of x to the r here, and then the r comes down here. There's all different ways you can do it. Okay, but that's sometimes helpful. That is about all I wanted to say about natural log. Okay, just reminding you of these guys. So, all right, I'll make another video of inverse trig functions, I guess, so it doesn't get too long.